In a previous video, we did the sum and difference formulas for sine and cosine. In this video, we're going to take a look at the sum and difference formulas for tangent. Our objective: use the sum and difference formulas for tangent to evaluate and simplify trigonometric expressions. Let's recall what we know. We know that the sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. The tangent of an angle is the opposite over the adjacent. And we know our unit circle trig values. I'll pull that unit circle chart out here. Okay, I've got most of it in there. And you'll want to notice what I did here on this one. This chart has, right on the outside of the circle, it has the cosine values and the sine values for our major angles. But further out beyond that, I simply did the math and I came up with the tangents for those angles. Remember, the tangent is the sine over the cosine. So for example, for 45 degrees, which is equivalent to pi over 4, root 2 over 2 sine divided by root 2 over 2 cosine is 1. And so all of these are the tangent values of those known angles that we work with. We'll come back to that chart in just a moment. Now with the sine and cosine sum and difference formulas, I derived them. I'm not going to do that with tangent. A bit of a pain, so we're just going to give those to you. Let's remember that I've combined two formulas into one here. The sum formula reads across the top. So the sum formula, the tangent of alpha plus beta, is equal to tangent alpha plus tangent beta, again, read across the top, divided by 1 minus tangent alpha times tangent beta. So the sum has a plus in the numerator and a minus in the denominator. The difference formula has a minus in the numerator and a sum or a plus in the denominator. Let's put it to use. Okay, I'll keep that formula up there for us. Given that the sine of alpha is 4/5, alpha is in quadrant 1. The cosine of beta is negative 12/13, beta is in quadrant 2. Find the tangent of beta minus alpha. Okay, let's draw it. Okay, so let's see here. Alpha is in quadrant 1. I'm not needing to be fancy. There's alpha. The sine is the opposite over the hypotenuse. And so the opposite would be 4. The hypotenuse would be 5. And of course, it's a right triangle, so I can use my Pythagorean Theorem and come up with the fact that the adjacent angle to alpha, or the length along the x-axis, is 3. Okay, beta is in quadrant number 2. So I'll go around to beta, somewhere over here. I will draw this out. It may not be precisely right, but this is my beta here. Okay, I will drop down a vertical to the x-axis. This beta is equivalent to this beta if I get the signs correct. Well, beta, this cosine, is adjacent over hypotenuse, so the adjacent must be negative 12. Again, the hypotenuse, the vector is always positive, and the hypotenuse would be 13. And so if I do the math using the Pythagorean Theorem, and I recognize that I'm in quadrant 2, where the y value is positive, this is positive 5. It's a 5, 12, 13 right triangle. Again, once we note that this is a negative 12 and a positive 5, we notice that we're in quadrant number 2. Okay, so we have a picture of that. Now we want to find the tangent of beta minus alpha. Okay, up here's our formula. The tangent of beta minus alpha is equal to the tangent of beta. Yes, the tangent of beta minus alpha. The tangent of beta minus the tangent of alpha divided by 1 plus the tangent of alpha. Excuse me, the tangent of beta, the first piece here, times the tangent of alpha, the second piece. So I switched these up on you. So so beta becomes alpha, alpha becomes beta in our formula. Just be aware of that. They're all just letters. They don't have any meaning until you attach meaning to them. Okay, tangent of beta. Here's beta. The tangent is opposite over adjacent. Opposite is 5, adjacent is -12. So this is -5/12 minus the tangent of alpha. Tangent is opposite over adjacent, 4/3. I'm not doing any math, I'm just recognizing what is what. Okay, divided by 1 plus, remember we're subtracting, so the numerator has subtraction, the denominator has addition. 1 plus tangent of beta times tangent of alpha. Well, that's not bad. That's just this one, -5/12 times this one, +4/3. Okay, if I do all that out, do my math, do my work, I come up with -63/16. Normally it makes sense to leave things as a fraction, unless called for otherwise, but that is the answer to the tangent of beta minus alpha. All right, let's take a look at a couple more examples. Get my papers together, my notes together. Okay. Again, in example 2, we want to find the exact value of tangent of 75 degrees. Now we know that 75 degrees is not one of our known exact value angles, but we recognize that if we add 30 and 45, these two we do know will get the same thing as 75. So we're saying that the tangent of 75 degrees is equal to the tangent of 30 degrees plus, I think I just slipped it on the paper, sorry about that, 45 degrees. Okay, this is alpha plus beta. Okay, use our formula. The tangent of alpha plus beta is the tangent of alpha, which in this case is 30 degrees, plus the tangent of beta, which in this case is 45 degrees, divided by 1 minus, we're adding here, so we add here and we subtract here, the product of the tangent of 30 degrees times the tangent of 45 degrees. Okay. Let's see here, tangent of 30. Okay, I go back into here and I look at my quadrant 1, 30 degrees, tangent is sine over cosine, which works out to be √3/3. So this is √3/3 plus the tangent of 45. I go back to my unit circle. I find 45 degrees. The tangent is the sine over the cosine, which I've already done the math. It's 1. So I'm going to add 1 here to that one, and this is going to be divided by 1 minus tangent 30 times 45. So this is √3/3 times 1. Okay, let's see what we want to do here. We can make this look a little nicer. Let's recognize the numerator. If I wrote 1 as 3/3, right? 1 is 3/3. The numerator is whoops, just a second, I got a little bit too quick. The numerator is √3 plus 3/3. Again, if I write 1 as 3/3, I have a common denominator, it's √3 plus 3. That's my numerator. Denominator, well, this is 1 minus root 3 over 3. Okay, this is 1 minus root 3 over 3. Well, hang on a second. I'll leave the numerator alone. 3 over root 3. Wow, I've done that twice now. 3 plus root 3 plus 3 over 3 divided by, well, this again, I can write this as a 3. 3 over 3. 1 is 3 over 3. So this is going to be 3 minus root 3 over 3. Okay? So again, if I write 1 as 3 over 3, I have a common denominator of 3, and I have 3 minus root 3 in the numerator. This is a complex or a compound fraction. I divide by multiplying by the reciprocal. So root 3 plus 3 over 3 times the reciprocal, which is 3 over 3 minus root 3. Well, those cancel because they're a common factor, and I run out of space down here. The answer is root 3 plus 3 in the denominator divided by 3 minus root 3 in the numerator. So we did a little bit of algebra practice there, a little number manipulation practice there. Okay, let's do one more example, then we'll be done. Okay, we want to simplify this expression, the tangent of x minus pi. Okay, well, this is alpha and this is beta. Okay, so the tangent of x minus pi, alpha beta, is equal to the tangent of x minus the tangent of pi. Tangent alpha minus tangent beta, we're subtracting, so we subtract on the numerator, divided by 1. We add in the denominator the tangent of x times the tangent of pi. Let's get my pi written a bit better. Now let's recognize that we're dealing with pi here, so we're in radians. Okay, the pi is telling us that we're in radians. And the tangent of pi, well, let's take a look at that. Okay, the tangent of pi is right here. Pi is equivalent to 180 degrees. What is the tangent? It's the sine divided by the cosine. The sine is 0, the cosine is -1. 0 divided by anything but 0 is equal to 0. The tangent of pi is 0. So this is going to become the tangent of x minus 0 divided by 1 plus the tangent of x times 0. Well, let's see. That just boils all down to the tangent of x over 1, which is simply the tangent of x. We simplify this expression. Tangent of x minus pi is equivalent to the tangent just of x. So there you have it. A fair amount of work there on the sum and difference formulas for tangent.